Well, here we are again. Who would have thought it, eh? So don't panic. I fully intend to cover what we would have covered in class. I'm just going to do a video for Thursday, which I'm doing Wednesday evening, and then I'll do another video for Friday covering the same content that we would have covered. And in fact, I want to start with the question that we got to at the end of Wednesday's lesson. So I'm about to go through the full solution to that. And so pause the video at this point if you haven't yet had a go at finishing that one off, and then watch the video and I will walk you through it. So we'd got to this point in this vector question. It wasn't a position vector question, but it sort of used the same techniques because we were told how to get from A to B. That was that, and we were told how to get from A to C. So we can work out how to get from B to C by going backwards down there, -3, -5, forwards along there. So that gives us 3 minus 2, -3 plus 6, and -5 plus 3. I then used the Pythagoras thing to work out the length of all three sides. So this length is 3 squared plus 5 squared, etc., etc. And I've left them all as surds and unsimplified. Well, you'll see why when we come to answer the rest of the question. Some of you will realise why straight away. Anyway, I've answered this question here. That is 3 minus 2. So that's the vector to get from B to C. The angle BAC. Firstly, which angle is that? That's this one. And at this point, I'm going to remind you of a couple of formula that you need to know. You need to know the sine rule formula, which is separate. You also need to know the cosine rule formula. And you need to know this formula to work out the area of a triangle if you don't know the base and the height. And I always learn it like this, although some of you at the schools, or if you've looked in revision guides, will have seen it like that. And it's these two formulas that we use in this situation. And I'm hoping that you will realise that to work out this angle, we use the rearranged version of this. So if you remember, I add that to both sides, I take that away from both sides, I divide both sides by 2bc, so I get cos A equals b squared plus c squared minus a squared divided by 2bc. And this allows me to find the size of an angle, which we're going to label A. And handily, it is already labelled A, but I'm going to label it with a nice big A there. And you remember that the way that we label triangles when we're not dealing with right-angled triangles is with capital letters and little letters. So if this is big A, that's little a, and this angle is labelled B. So if that's big B, this is little b, and if that's big C, then that's little c. But you'll remember that B and C, it doesn't matter which way around you do them. So I know that cos A is equal to b squared. Well, the length of B is square root of 45, so that squared is 45. Square root of 45 squared is 45. That's why I left it as square root. Plus c squared, which is 34, minus a squared, 13, and that's all divided by 2 times b, square root of 45, times times c, which is the square root of 34. And so I'm going to do shift cos of that whole calculation to get the size of this angle here. We all know that there are lots of angles that have a cos of equal to this, but this is clearly an acute angle. So the first angle my calculator tells me is hopefully going to be the one. And wouldn't you just believe it, I left my fancy calculator at home, so I'm having to slum it old school, GCSE style. So anyway, go on, see if you can finish that one off. Okay, so 32.5 degrees seems reasonable, and that is that. And then the area, well, the reason I use this version rather than this version is that I've just worked out the size of this angle, and it's called A, so it seems to make sense to have angle A there. Now, I know I talked in class about the whole idea of if you know what cos A is, there's a proper way of working out what sine A. We wouldn't use that in this situation. So in this situation, I would store this exact value and then I would plug the numbers into this formula. B is still root 45, C is still root 34, and it's the sine of the exact value from there. So go on then, have another go at, pause again and have a go at that one. Okay, and there we go. Comes out as a nice round value, bizarrely. So, and I used my stored value, so that was all good. Okay, so hopefully you got somewhere with that. Now let's move on to what I was planning to do in Thursday's lesson, which is a bit of circle practice. Okay, so first things first, I'm hoping that you're able to answer part A with the information you've given here. Remember, to write the equation of a circle, you need two things. You need the centre and you need the radius. Well, we're given the centre and we're given a point that on the edge of the circle. So we can work out the radius by working out the distance between the centre and that point. So I'd like you to pause the video at this point. See what I did there? And see if you can have a go at A. For part B, all you've got to do is when you get your equation, make sure that it works when x is 3 and y is 6. Okay? Right, pause and have a go. Okay, so here's my centre. Here's the edge of the circle with the point. So working out the distance between the two, from -2 to 1 is 3 along, 5 up. So working out the radius using Pythagoras, I get the square root of 34. So I know the centre is -2, 3. The radius is the square root of 34. So this is the standard equation of a circle. It's x minus the x-coordinate of the centre. So that's x minus -2, which is x plus 2. And y minus the y-coordinate, y minus 3 squared, equals the radius squared. And as with the vector question, square root of 34 squared is 34. And when I make x equal to 3, that becomes 5 squared, which is 25. When I make x equal to 6, that becomes 3 squared, which is 9. And those two do make 34 as required. Okay, so we're now asked to find the equation of a tangent to the circle. So this is another point on the circle. So it's a point up here somewhere. 3, 6. Now I know to work out the equation of any straight line, I need two bits of information. I need a point and I need a gradient. Got the point? What about the gradient? Well, the gradient of the tangent, so the tangent will be a line that touches the circle up there, is going to be perpendicular to the radius. That's one of those circle angle rules that we learnt in GCSE. A radius and a tangent are at right angles. So what I'm actually going to do is going to work out the gradient of this radius, much like I did here, except I worked out the length, not the gradient, but similar sort of calculation. That gives me the gradient. I've got the point. It's the tangent they want, so it'll be the minus flipped version of the radius to use to get the tangent of the gradient of the tangent, and then you should be okay with the process. Again, pause and have a go. Okay, so the gradient of the radius was 3/5, so that means the gradient of this tangent, which is perpendicular, minus 5/3. So we know the equation of the tangent will start y equals minus 5/3x plus something. To work out the something, we substitute in 3, 6, so y is 6, x is 3, but minus 5/3 times 3 is just minus 5. And so c is 11, so blah, 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 multiplied by 3, and we get it in the form which they want. So that's sort of the basics of circle equations. Let's move on to a second question. So here's the second key technique, and that is taking the expanded version of the equation of a circle. So that's if you take the bracket version and multiply out the two brackets, and writing it back in this form. Where AB is the centre and R is the radius. So, hopefully you can remember the technique. If you can, pause, have a go, and then we'll go through it. Right, so here's what I'm going to do. I'm going to write the two x terms together, and then the two y terms together. And then the number I'm going to shove to one side. Sometimes that's on the left-hand side of the equal sign and you've got a 0. In this case it happens to be over there, it makes no difference. Right, if I want this to be written in this form, and the minus there is irrelevant, it's just reminding me that that value is the opposite of what the centre x coordinate is. So if I want this in a completed square form bracket, I know that it's going to have x minus 1 squared, because that gives me x squared minus 1x minus another x plus 1. And x squared, tick, minus 2x, tick, plus 1. Haven't got a plus 1 here. So if this is to be the same as this, you've got to take away 1. Going to do the same here, so I get y plus 3 squared minus 9 for similar reasons. And then I sort it all out. So I've got my x minus 1 squared and my y plus 3 squared. I've got minus 10 over here, which I then add over here gives me 36. So I know my centre is 1 minus 3, opposite of that, and the radius is the square root of that, 6. Easy peasy. Okay, so this question is much like the previous one, except we've got a missing value which we need to work out first. So to work out the missing value, we're going to substitute in x is 1 and y is 5, and that will just give you an equation with numbers and k, and we've got to make k whatever it needs to be to make the answer 0. Then, once we've got that, the process will be the same as the one we've just done, taking the expanded version and writing it in the bracketed version. So, again, pause, have a go. Okay, so k is minus 14, substituted in 1 and 5, and so I've rewritten this in the way I recommended. X terms together, y terms together, number out here. At this time it's on the left of the equal sign, doesn't matter. So that is going to come from that, and that is going to come from that. So I get y plus 4 squared and y minus 2 squared, and I've got minus 16 and minus 4, so it's minus 20, minus 34. When I add that to both sides, that gives me 34. So I've got a centre, remember it's the opposite of that, minus 4, 2, and the radius is the square root of 34. Okay, so the problem goes on and says a straight line passes through the point 3, 7, and it's a tangent to the circle at the point B. Sorry, straight line passes through the point A and is a tangent to the circle at the point B. Find the exact length of the point B. So I'm going to give you a minute to have a think about that one. Well, sorry, you can have as long as you want. You're going to pause the video and then I'm going to walk you through a solution. Now this is a bit of a stinker, this one. So whenever I get a bit stuck, I always definitely start with a sketch. So I've sketched the centre of the circle and this point A. Now we're not told that A is on the circle, but it's on a tangent which touches the circle somewhere else. Now that implies to me that A is outside the circle. I mean, I think that's the only way it can work, but I'm just going to double check that by working out the length of C to A. I know the radius of this circle, remember we just worked out, is the square root of 34. So I'm just going to check this is longer than the square root of 34. So that's proving it's outside the circle. So that's minus 4 to 3 is 7. And 2 to 7 is 9. So yeah, clearly this is going to be longer, isn't it? So we've got 7 squared is 49. And 9 squared is 81. So I've got the square root of 130 is that length there. So what we must have, therefore, is this point B, which is the other point that the tangent A passes through, is on the circle. So I don't really know where B is. It could be down here, it could be up here. So I'm just going to have a punt. I'm going to say it's up here somewhere. Now that's so it's got to be something like that, isn't it? So this is point B, which is on the circle. Now, I don't know the coordinates of B, but one thing I do know is that if that's a tangent, that's got to be a right angle. So angle between radius and tangent is a right angle. I know this length here, so this is now my hypotenuse in a right angled triangle. I also know this length here. This length here is the radius. And I'm not asked for the coordinates of B, I'm just asked for the length of AB. Well, this is a Pythagoras problem, isn't it? Because Pythagoras says that this squared, which is 34, added to this squared, gives me that squared, which is 130. So I know that this length squared is 96, so the length of AB is square root of 96. A bit of a clue, there was going to be a square root in terms of the fact they said exact, and my calculator does all the simplifying for me. Okay? Now, you'll recognise those questions coming from Maths Genie. You may feel you need to do more, you may feel that's enough. But there you go, I'm going to leave it there. If you've skipped through this because you feel you know enough about circles, that's absolutely fine. But do make sure that you are targeting your revision on the topics that you feel you really need to do. And Friday, I will carry on with the topics that I said I'd revise, but I'm very, very happy. I've got some time on Thursday now, obviously, not teaching you. Very happy to prepare video solutions for selected questions from that paper too. So go on, I'll open it up to requests. If you've got a question on there that you'd really like to see a full solution to, then drop me an email. Okay? I do hope you are all well and you are taking advantage of the opportunity to crack on with your revision in all your subjects. Take care.